Okay, everybody, I hope you survived the snow. It's been fun, but it's going to be crazy to get the car out today. So anyway, well, welcome. We're just going to talk quickly about two things, and they're pretty darn simple, but it's fun to see examples. One of them is differential equations, how to separate them, how to solve them, solve for an initial condition. We've done that a little bit. And then exponential growth and decay, what that looks like, how you can solve equations that are connected to real-world problems. So anyway, so here's the deal. If you have a differential equation, if you take a look at number one, and I'll warn you right now, my pen is really lame. So I don't know how, nope, that wouldn't work. Wrong pen. Let's see, having issues here. All right, so I'll tell you right now, the pen is kind of weird. And it's looking like I'm having trouble. All right, here we go. Okay, so you have something in this form, and the idea is to get the y over to the other side of the equation and to get the dx over to the other side of the equation. So the way I do that is to multiply by y. So I get y dy equals, move the dx over, I get 2x dx. Now, when I'm in this form, I now can integrate. So notice these are, y dy is acting like a derivative, and so is dx dx. So in order to solve this, I need y equals blah. Hopefully it has x in it, because y is the independent and x, nope, just kidding, y is the dependent variable, x is independent. So I'm going to integrate these. You know that this is y squared over 2. And I told you my pen was silly, equals, well, 2x squared over 2 leaves you with 2, just kidding, x squared. And we'll put the c on the right side. We'll keep putting the c on the right side. You could put it on the left if you must. You'll get a minus c on the right side, which is fine, because remember, a constant is a constant is a constant. So the idea is to solve this. I'm going to multiply through by 2, so I get y squared equals 2x squared 2x squared. Now, many people would say, oh, plus 2d. Now, you don't want to do that, because remember, this constant could be negative 500,000, it could be 2, it could be negative 1/2. We have no idea. So I'm just going to make that a different constant, which is d. So we're solving for d, which is secretly 2c, but c doesn't mean anything except for somewhere along the line I have a constant. Because remember, differential equations have to do with slope fields. I could have drawn a slope field for this. And then I've got lots and lots of solutions. So we're going to find a particular solution for this differential equation, where exactly it is on the xy plane, based on that, which is the 0.46. Okay, so let's square root everything. Bam. And you know, if I'm square rooting everything, I've got plus or minus, right? I get y equals plus or minus, and we're going to choose one of those. And think about just for a second, how would I choose whether it's plus or minus? I've got 2x squared plus d all underneath the square root. And I'm being very careful because this is very hard to write with. And I've got a plus or minus to choose from. And what you do is you look at the point. So my point is up here at 4, 6. I could either be a positive or a negative square root. So I'm either going up above the x-axis or below. Well, obviously, we have to go above the x-axis. This itself is not a function, but if I go above the x-axis, I'll include that 0.46. So let's grab just the positive, and then we're going to work with that. So plus or minus square root of 2x squared plus d. Bam. There's a delay when I write this, so that's why I'm talking over myself. Talking over myself. Okay. So I've got that. Now I get to solve. So I'm going to use the 0.46. 46. And I'm going to solve that. So I'm going to throw a 6 in for x. I'm going to keep the positive square root and put a 4 in for, did I say x? I meant y. 4 in for y. So I've got 2 times 4 squared, squared, plus d, all of which is under the square root. So I got to get rid of the square root, so I'm going to have 6 squared is 36. The square root is gone, and I've got 16 times 2 is 32. And hopefully you guys can see what happened. I squared everything plus d. Now to solve for d, just throw the 32 on the other side, and I'm going to get 4 equals d. And I'm going to apologize right now because my cat just jumped on my desk, and he loves to close programs, so hopefully we won't lose anything. Okay, so my solution to this is y equals the square root of 2x squared plus 4. All that's under the square root, and you might say, who cares? What difference does that make? So I solved a thing, I got the initial condition. Well, my favorite thing to do is to look at the graph, as you know. And the graph is actually a hyperbola. You wouldn't necessarily know that without having done 100 billion of these. But it's a hyperbola, and if I were to graph the positive and the negative part, that's what it looks like. And if you put that equation into your calculator and you trace to 4, you look at the table, you're going to see this little point, 4, 6, which really does lie on the parabola, which is way cool. We found one. You remember, there are a billion of these, maybe a trillion of these. So if I am, you know, I could draw a billion of these, all going up the x-axis, all going down the x-axis. Here's another set. So more and more. But we found the actual solution, which, if I can highlight this, which apparently I cannot, well, maybe I could do this. We found this guy. Here he is. Happy hyperbola facing up and down. Now, really, the only part that I should have is the top part. But that's okay. It's kind of fun to see the whole thing. Now, I would ask if there are any questions, but clearly you can't ask them. So let's move on and look at number 2. So check out the y. It's on the right side of the equation. dx is on the left side. That's easy to fix. But I need to divide everything by y squared. So I'm going to get 1 over y squared. Ooh, I'm in purple. How exciting. Equals, and I just have 1 dx. And check out the solution that I'm dealing with. I've got 3, should be 3 negative 1. So I'm looking for a solution to this differential equation that goes through 3 negative 1, and that dy is still on the right. And I get to integrate this. So I know the integral of y squared, which was y to the negative 2, is now negative y to the negative 1 equals x dx, nope, just kidding, x plus c. See, it's good to have this lag because I can correct myself. Okay? Well, that's the same as saying 1 over y equals x plus c. That's a 1 on top. Let's see, 1 over y equals 1, just kidding, x plus c. If I want to correct that, because I don't want 1 over y, I want y, so I'm just going to flip it upside down, and I'll have negative y equals 1 over x plus c. Bam. X plus c. Oh gosh, this pen is being really weird. It's interesting. You know, I went out and I love you guys so much. I spent $100 on this thing. So I am dedicated to your knowledge. Let's see. So what I'm going to do is multiply both sides by negative 1. So I'm just going to get y equals negative 1 over. And I hope you guys printed out the notes. They're on Blackboard. That way you can follow along. You don't have to frantically write stuff down, which would kind of stink. So there's my solution. Now I want to look at c. I need to know what c is equal to. So I'm going to plug in my x and y. And remember, I've got 3, negative 1. 3, negative 1. Okay, so I'm popping a negative 1 in for y. I am popping, like popcorn, a 3 in, oh my goodness, 3 plus c. You know what's funny is this is a drawing program, so I'm supposed to be drawing exciting things, and instead I'm doing math, but it's okay. I think you shall survive. All right, so I'm getting, what am I getting? The 1s are gone. I'm going to get 3 plus c on the top. So here's 3 plus c is equal to 1. And if I subtract 1 from both sides, I'm going to get c is equal to negative 2. So my equation, I'll write it way up here because I don't have a lot of room, is y equals 1 over, that should be an x, minus 2. And you guys know what this graph looks like, right? It has a asymptote at 2. Okay, if I can make this thing draw a happy graph. You've got an asymptote at 2. So here comes my asymptote. And I've got an equation which is going to graph a hyperbola, which looks like this. And I forgot my negative up here. That's important because my hyperbola is going through the second and fourth quadrant, which is what you would expect. And if you put that into your calculator and you graph, you get the point. So like down here is 3. And this is how you can check yourself. I love checking with a calculator. You want the graph to match the stuff that you're doing. In fact, there was one I was doing later on, and I knew it was wrong. I knew I had a mistake because it didn't fit the graph. So it's a good way to check yourself. So that's supposed to be 3, -1. It's kind of hard to see because it's hard for me to write. But again, I could draw a billion solutions in here, maybe a trillion if I have time. And the only one that matters is this one. So I really like to highlight things, but let's see if I can. Oh, I can. So this is the only solution right there. Just like here, the only solution was this hyperbola. And really not the bottom of it, because we chose the positive square root. Okay. So let's see what's going on for the bottom. I shall change pens because I like to write in color. All right. Okay, so let's scroll down here. Now this equation is supposed to be, if you look at your packet, it's equal to -4y, with -3, -5 being the point of interest. So again, what I'm going to do is I'm going to divide both sides by y and check out the fact that I'm leaving the 4 on the right side. It's easier to do that than have the y stuck with the 4, and then you have to integrate and keep track of that constant. Whereas if you leave it on the right side, it's really no big deal. If I divide y by y, I get just -4. Oh, this pen's getting worse. Oh my goodness. That's it, just -4. So 1 over y dy is -4 dx. So again, I integrate both sides. I'm going to get ln y. Keep the absolute values until we know that we're good. It's going to be -4x plus c. Okay. And if I want to solve ln, I need to raise it to a power. So I'm going to raise both sides to the e. We call it e-ing both sides or exponentiating both sides. Same story. I get y. Now e to a power is still a positive. So the fact that I've got e to a power on the right side is cool because whatever y is, it's got to be positive because e to any power is positive. So I can drop the absolute values on the left. I'm going to have e to the -4x plus c. Check out the fact that the c is in the exponent. And from the rules of exponents, I don't know if you remember this, but this is e to the -4. Wow, how did I do that? -4x. Let's just make it look like a 4. Times e to the c. But e to the c is a constant. So I can rewrite that as y equals, holy cow, oh my goodness, I hate this thing. E to the c is just c. E to the -4x. Okay. So e to the c is a constant. That is a beautiful thing. So I can just write a big old c and solve that. So I'm using the point -3, -5. So here it is, -3, -5. And I'm throwing a -5 in for y equals some constant c, e. -4 times -5 is 20. So I don't know why I have a 12. Oh, -4 times -3 is not often 20. It's usually -12. And they're both negative. Maybe I'll write this step, and then you'll see what I'm talking about. Trying to do math in my head is a dangerous concept, as you well know. Okay, so that's e to the 12th. I'm going to divide both sides by e to the 12th. Okay, so I've got 5 over e to the 12th equals c. And that is supposed to be a -5. So there's my c value. And I can put it all back together. So my equation is y equals negative 5 over 12, or e to the 12th. It's crazy pen. E to the negative 4x. Okay. So there's my solution, and again, my interest is always, who cares? What in the world does that mean? So I graphed it. And if you graph it, you can make the negative 5 over e to the 12th. Hopefully you know how to store that in your calculator because it makes it so much easier to graph it. Throw it into y1, graph it like you mean it, and you've got an asymptote at 0, y equals 0, and the little point in question is down here. So negative 3, 5 is right there. All right. Okay, so hopefully you're with me on that. Notice anytime I've got something that's e to the x, and on the right side I've got e to the 4x, let me show you what I'm talking about. Here I am right here. Anytime I've got y equals e to the something that's added, that c is e to the c. I can just make that a giant c. So I can go straight from this step to c with no worries. So let's see what happens in the next one. It's the same sort of story. It is a most beautiful story about math. Let's do this in green. I'm liking green. We're getting towards St. Patrick's Day. Well, it's not really. Okay, so this one, that's an equal sign. Now you guys have the packet, so I don't always have to like enunciate that. But I'm going to divide by y. So I've got 1 over y dy. And the only difference with this is that the 4y is now positive, not negative. So you might say, well, what's the difference? I'm going to show you the difference. This is dy equals 4 dx. Integrate. I'm going to get ln y just like I did before. Ln y equals, again, 4x squared over 2 is just plain old x squared. X squared. There should be a 4. Oh, nope, 4 over 2. So I've got, goodness, what do I have? So I've got e to the 4x. So I just realized there's something silly about this. I think I'm able to erase. Let's see if I can erase. Maybe I can just grab this and move it. Nope, don't want to do that. This is technology at its best. Okay, so here's what I'll do. I'll just rewrite. I'll just write right over it. That's fine. So I got 4x, no squared, plus c, just like I did before. I'm going to exponentiate both sides. So I get that e to the c, which just becomes c. So I get y is equal to, and I'm just going to call that right away c e to the 4x. Okay. Now I get to use 2, 7. So here I am, 2, 7. Throw a 7 in for y, a 2 in for x, and I get c e. 4 times 2 is 8. Divide everything by e to the 8th. So I get 7 over e to the 8th. E to the 8th equals c. Okay? So that's my coefficient. Put everything back together again. So I'm going to get y is equal to 7 over e to the 8th. It's fun to store that if you remember. You just put that on your calculator and hit stow and pick your favorite letter. So I got 7 over e to the 8th, e to the 4x. And again, I am all about looking at it on the graph, so I know what does this relate to. Well, you can imagine this is an e function. It's going to go through 0, 1. It has to, right? Because if 0 is x, it's got to go through 0, 1. So it just is facing up instead of down. And if you trace over to 2, you get this point, 2, 7. Okay. And again, I would ask if there are any questions, but of course there aren't, because you're not here. Okay, now there should be a new page, and I think there should be a new page with some stuff on it. And there it is. Just have to scroll up. Okay, so just let's look at some other ones. And I want you to stop the tape, or whatever this is. Just stop the recording for a second and try this one. So just hit stop. Try number 5. That's supposed to be y minus 4 over x squared. Okay, and I'll even stop the recording if I can and let you do that. Okay, I'm back. So let's take a look at this. I want to leave the x squared on the right. I want to move the y minus 4 on the left, which means I got to divide by y minus 4. So I get 1 over y minus 4. And then y prime is just dy equals, I'm going to call that x to the negative 2, just so when I integrate it, it's easy to look at. Okay, and hopefully you integrated this, and you know the y has no coefficient except for 1 in front of it, so I can skip right to ln y minus 4 equals, so that becomes negative x to the negative 1, put a plus c on the end, and then we're going to exponentiate each side. So I got e to the thing equals e to the thing, and I get y minus 4 equals, now that's just e to the negative 1 over x plus c, and the plus c is all part of the exponent, which we now know I can just say, hey, whoa, check it out. I got a c on the right side, because e to the c is just some constant, e to the negative 1 over x. So I'm ready to put the point in. Now you can put the 4 on the right side if you like. I just thought it would be fun to stick a 0 in for y right now, minus 4 equals, and we're going to check out c, because that's what I'm interested in. And this should not be 4, that should be an x. So, my bad. Right there, that's an x. I stuck a 4. I was so excited I stuck a 4 in there already. So I get e to the, now I can put the 4 in. So negative 1 over negative 4. Or I could just say e to the negative 0.25. Okay. So I got negative 4 equals c e to the 0.25, which you don't have to write it like that. You can keep it 1/4 if you like. I just thought 0.25 would be more expedient. And then grab that e to the 0.25 and throw it on the bottom of 4. 0.25. You know, this pad is secretly for drawing. Oh, I think I probably already told you that. Anyway, so you can see it's c equals negative 4 e to the 0.25. That's what that's supposed to say. Bam. Make the 5 look better. Okay. So let's put it all back together again. I'll put it up here. Y equals negative 4 over e to the 0.25 and it's supposed to be a parentheses, and it'll be e to the 1 over x. Okay, e to the 1 over x. And I believe that is negative. So again, I look at something like that and I say, oops, sorry, there's a plus 4 in the end. All right. So just to check out what that looks like, if you're really careful with parentheses, or if you store that negative 4 over e to the 0.25, you're going to get a graph that looks like this. And it's going to go through negative 4, 0, be asymptotic to the y-axis. And the point negative 4, 0 is right there, negative 4, 0. Okay. All right. So let's look at the next one. I'm also going to do something where I look at its domain because it's interesting what the graph looks like. On the bottom of here, there's a y. And let me switch pens so that it's just not confused with the other one. So we'll go into red. So there's a y down here. All right. Same story. Put the y on the other side. So I've got y prime, or dy, which I like better, equals 3x squared dx. Integrate it. So you're going to get y squared over 2 equals 3x squared becomes 3x cubed over 3, or just x cubed, plus c. Now when I multiply through by 2, remember I'm going to leave the constant out of it. Because a constant is a constant is a constant. I have no idea what it is. I don't really care. Well, I am going to care what it is. That's the whole point of this. But I'm going to call it d. Because if I do that, then I'm just saying to myself, the d, it's a constant. I don't know what it is. It's probably affected by the 2. So whatever it is, it's twice that, but it doesn't make any difference. And again, I've got y squared, so I'm going to square root everything. And then I'm going to look at the point that I'm interested in. So it would be plus or minus the square root, but I'm going to pick the minus. Because look at your point. 1, -4 graphs beneath the x-axis. So I'm going to call this minus, which is supposed to be this right here. Okay. And we can plug the point in. So 1, -4 goes in for this. And I never really did solve that, did I? So I'm just going to say, so this should just be y equals negative square root of 2x cubed plus d. So put the point in there, -4 equals negative square root of 2x cubed. It's just 2 because it's 2 times 1 plus d. If I square both sides, I'm going to get 16 on the right, I think, equals 2 plus d. And notice I didn't even distribute that -2. I could have and had 2 minus d. It doesn't really matter because d is just whatever the heck it is. So I'm going to, what am I going to do? I don't know what I'm going to do. Let's see. Okay, so I had to just figure out for a second what I did. I divided both sides by -1. So this became positive. So I just didn't feel like having the negatives. If you subtract 2 from both sides, you get 14 equals d. And put it all back together, I shall get y equals negative 2x cubed, it's all under the square root, plus 14. You're probably way ahead of me, aren't you? We're going to look at the domain for this, like I said. There's the particular solution for that differential equation. And what was interesting is I looked at the graph for it, and your calculator does something like this. It kind of does this, and it stops. And I was so interested, I said, well, what would the domain be for that? And does it really look like that? Is my calculator lying to me? Because do you know your calculator does lie? So let's look at the domain. You know that this stuff underneath the square root has to be positive or equal to 0. So I'm going to let that be greater than or equal to 0. So plus 14 must be greater than or equal to 0. Subtract 14 from both sides, so I get 2x cubed is greater than or equal to negative 14. Divide by 2, so I get x cubed is greater than or equal to negative 7. And then cube root everything. So x has to be greater than, whoop, I put a cube on there. Did not mean to put the cube. Let me see if I can get rid of the cube. Goodbye, cube. Maybe I can delete it. Okay, cube has been removed. All right, so x is greater than or equal to cube root of -7. But you know cube roots of negative numbers are the same as the opposite of the cube root of the number. So let's see, x is greater than or equal to negative cube root of 7. So that means everything to the right of cube root of 7 is cool. Everything to the left is not. And if you trace to the negative cube root of 7, your calculator's lying. It's actually up here. This is x equals negative cube root of 7. So you can tell if your calculator's lying by doing the math on it. Why not? You know more than your calculator. You know that. And this goes on in this direction. And then the interesting point that we found was 1, -4. So it's right here. 1, -4. Bam. It's supposed to be a 1. Okay? All right, so we got one last one, and then I will stop, and you can muse on this, maybe meditate a little bit on math. Go outside, play in the snow, get your cars uncovered, should your car be covered. All right, I'm going to stop the recording for just a second, let you guys work on this one, and then I'll pick it back up. Okay, so hopefully you guys had a second to do this. I don't know, I think this thing is missing something. Maybe not. Yeah, this is -t up here, which you see on your sheet. I just wanted it up here for anybody who's looking has no sheet. No sheet. Okay, so we're going to leave the x on the left side. So I've just got x dx on the left. Moving the e to the -t is going to put it on the bottom on the right side. So e, well, nope, it's not going to do that. E to the -t, that's like e to the t over here. And that's negative plus c. So hard to write this. Okay, plus c. So if I integrate both sides, now remember e to the -t, this is the same thing as e to the t, right? If I put it up into the numerator. So x dx is now x squared over 2. E to the t is my favorite function. It is its mama and its daddy and its baby, which is so strange. It's e to the t plus c. And then I can move the 2, which is fine. I'm going to get x squared equals 2e to the t. But again, I do not want to do something like 2c. It's going to throw off my solution because it's really not 2 times a constant. I don't know what the heck the constant is, so it doesn't matter. We'll make up a new one. Notice something else that's interesting about this. I've got x defined in terms of t. So my dependent variable is x, independent is t. So this is y equals f of x, only if x is f of t. So when I'm solving it, that's why I have the x squared on the left side. Square root, everybody, and look at your solution. Look at where it's supposed to be graphing. It's 0, 1. So it's above the x-axis. I'm going to pick the positive square root. Positive square root of 2e to the t. E to the t plus d. Okay, so hopefully you're listening to me and not looking too badly at the thing. All right, let's use the point. I've got 0, 1. And so I throw a 1 in for x. If I put a 0 in for, that's e to the t, right? That just becomes 2e to the 0. 2e to the 0 is 2 plus d. Okay, we're going to square both sides. I'll still get 1. The square root just pops off, 2 plus d. Subtract, and I get d is equal to -1. Okay, put it all back together again. So I've got square root of 2e to the t minus 1. So here we go. X equals the square root of 2e to the t minus 1. And what's interesting for this, again, it's a square root. And here's the graph that I got. And I didn't like it because I thought the graph on your calculator just stops here. And I wanted to know, well, is that right or not? If you solve this stuff, just like we did in the last equation, you're going to get t must be greater than, you guys can go ahead and solve this on your own. It has to be greater than or equal to ln 0.5 or ln 1/2. And if you go on your graph and you say, hey, give me ln 0.5, that's it, ln 0.50. So it does touch the x-axis. It doesn't go beyond that. It can't because that's outside of its domain. So that's what this is. That's not the point that we were looking for. We were actually looking for the point on the x-axis, which is this point. And I must switch pens because color is so much fun. Okay, so we were looking for this point right here. And that truly is 0, 1. Okay, so that's it. That's it. You've got differential equations. You have a worksheet, I believe, on that. This is really only part 1 of the first day. I'm going so slowly because, why am I going slowly? Because it takes absolutely forever to write on this thing. So what you have so far that you can work on is 575, 577, those problems. You could start on the AP problems, the 2004 problems. So it's all on that first page where it says day 1. You won't have all of the information I'm putting into a separate recording, the exponential growth or decay. So I will be back. I will post this, and then there will be one more thing for you to listen to. So have a fun day. It's Sunday, which rhymes with fun day. So you should have a fun day, and I will talk to you later. Okay? Have fun. Bye.